Let's take another example and see how we can crash a project. So in this project, we would like to reduce the duration of the project by 4 days with the least possible cost. Which activities should it crash? You have 8 activities and their durations and maximum durations and the crash cost per day. And we have the activity on node network. The project's completion time is 19 days, and we want to crash this project by 4 days at the least possible cost. So first, let's find the critical path. Let's list all the sequences from start to finish. You have A, B, D, G, H, B, E, G, H, and C, F, H. And let's compute the length of each activity. The length of the first one is 4, 6 plus 4 and 3. That's 17. The second one is 7 plus 3 plus 4 plus 3, 17. The last one is 5 plus 11 plus 3, that's 19. So the critical path is CFH, and the project's completion time is 19. And we want to crash this project by 1 day. Which activity should it crash? Remember, we need to crash a critical activity. So we have 3 critical activities, C and F and H. Which one is the least expensive one? Between C and F and H, which one is the least expensive one? H. H is the least expensive one. So what happens if we crash H? Then the first one becomes 16. The second one is now 15. And the third one is 16, and the third one is 18. And the critical path is still this, and the project's duration is 18. Now, next, if you want to crash this project by 1 more day, which activity should it crash? Again, we have to crash a critical activity, and we have 3 critical activities, and the least expensive one is H. Can we crash H? No. Its maximum reduction is 1 day, and we already crashed it by 1 day. So we need to choose between C and F. Between C and F, which one is least expensive? C, so let's crash C. So what happens if you crash C? The first one is still 16, and the second one is still 16, and the third one is 17. Now, we want to crash this project by 1 more day. Which activity should it crash? Again, we need to crash a critical activity, and between C and F, which one is least expensive? C, so crash C 1 more time. If you do this, then the first one stays at 16, the second one stays at 16, and the third one becomes 16. Now, next we want to crash this project by 1 more day. Which activity should it crash? Now, here we have a tie. All of them have the same length, so they are all critical paths. So we need to crash all of them. So let's look at the first 2 paths. They have common activities, G and H. So if you crash one of the common activities, we are crashing both of them. But H, we've already reached the maximum reduction, so we can't crash H anymore. But you can also you can crash G and crash these 2 paths at the same time. But is this the only way to crash both of these? No, there are other options. Well, you can choose A from the first path and B from the second path. That way you can crash both of them. Is this the only way to crash both of them? No, you can do A and E. That way you can crash both of these paths. Or you can do D and B, D, B, or you can do D and E. So these are the 5 ways to crash both of these activities, both of these paths. So which one is the least expensive one? Let's compute the cost of each option. If you crash G only, it's going to cost you $14.50. If you crash A and B, it's going to cost you $3,300. If you crash A and E, it's going to cost you $1,300 plus $1,100, $2,400. So this way, you can compute the cost of each of these options. And it turns out that the least expensive option is G, right? So by crashing G, you can crash for both of these paths. So now we are left with the third one. How can you crash the third one? So we know we can't crash H anymore. And between C and F, which one is the least expensive one? Between C and F, C is less expensive, so we crash C. So crash C one more time and G. Then the length of these paths will be 15, and the project's completion time is 15. So here is our answer. You crash H by 1 day, and C by 3 days, and G by 1 day. So that way, the completion time of the project is 15.